Hello, I think we're live now. I'm just gonna wait a little bit. Do 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 do. I am just waiting for the confirmation on YouTube to say that I'm live, and then I'll start talking to you guys. But until that happens, I'm gonna wait a little bit. There you go. There you go. I think we're live. Welcome to the stream, everyone. I think there's already 2-3 people watching us, so yeah, welcome. Ayub, I think you are one of them, so thank you for letting me letting me review your project, my man. And yeah, today it will most likely be a code review for about an hour, maybe even less than that. It will not take a lot for me to review here. And after that, maybe we'll do some more C++. I don't know which project I'll work on. Maybe I'll work some more on the ECS. Maybe I'll go back to the Nintendo, the assembly emulator that we were creating before, which is the 65K, right? But anyway, so the idea for this stream is to actually review some of the code that Ayub has written. Ayub is one of the viewers, the long-term viewers. I think he started watching us over a year ago, if I'm not mistaken. So yeah, thank you very much, Ayub, for still being here. And he kindly volunteered his own project for us to review. So it's called ElectroBench. I believe this is supposed to be a OpenGL benchmark. I haven't really run it yet, if I'm honest with you guys. But maybe we'll get to do that if the code looks good and I know that it's not going to mess up my computer. So first things first, let's actually look at what README information we've got here, right? And then we can maybe give Ayub a little bit of feedback to improve this in the future. So ElectroBench is a 45-second long benchmark specifically designed to run on old and modern PCs. Don't criticize it. Using OpenGL 2.3 and GLSL 1.2, 1.3. So which one does it use? 2.1 or 3? Because they are different, Ayub. I guess a different version here will perhaps use, like, you know, version 1, I guess we'll use OpenGL 2 and then 2.3. Is that correct? Let me know in the comments, Ayub. And GLSL, so you've got some shaders, I believe. Even an Office PC should have low. Even Office PCs have low scores out here. I mean, Office PCs are kind of shit, my man. They are not good in today's world, I'll tell you that. No, it's by version. Alright, fair enough, yeah. That's what I thought. I thought that your newer versions will have like a 0.1 uses 2 and 0.2 uses 3, right? Did I get that right? Okay, cool. Thank you, nice. It is designed to be a replacement for GLMark. I have never used GLMark, so let's Google that just to see what you're competing with in here. GLMark. Have I used GLMark? I can't remember now. No, I don't think I've ever used it, but yeah, cool. Effects. Oh, you've got some effects, some graphics effects. So in V 0.1 alpha, we are using Lambertian, bling, and Phong lighting. Nice. That is, I learned that. I learned about that at university. I remember that now. And FBM based of 3D simplex noise to make a procedural texture, and then mixing the lighting and texture together, and then adding some effects like bloom, pulsating color, UV distortion, shadowing, and vignette effect. Also, the benchmark calculates the score and prints in the terminal. In version 2.0, in version 0.2, my dyslexic head is not letting me read this. We are using 3 noise types with high precision and then mixing them and remixing them. Then we use Phong lighting with no ambient color plus Fresnel reflection. And we use material procedural textures using noising like brick texture, metal texture, and noise color, and then mixing them with lighting it on the screen. It's a bit heavy. It's a bit heavy on information, but it sounds very fancy, Ayub. It sounds like a really cool project. Man, this is like stuff that you do at university, you know. And I know that you are quite a young guy, so if you understand this, it's very impressive, mate. It's very impressive. Anyway, so how is the score calculated? The score is calculated using the formula number time FPS, number of frames per second, times 12 over ft. I don't know what ft is. You know, that maybe you can put some more description on how your OpenGL benchmark actually calculates, you know, the final score here. Because looking at this, I don't really understand it very well. And overall, these two sections, they look good. I mean, I like how you explain what your project does straight away. And it would perhaps make it a little bit more clear if you actually said, specifically here at the very start, like if you want to test with OpenGL 3.x, use version 0.2. Otherwise, use for other PCs, you can use 0.1, right? Which is cool, very cool. There are minor grammatical errors here, but I'm not going to complain. I know that you're not really an English speaker, right? So you know this sounds fine, man. It's not too bad. So well done, Ayub. Now, how to run Debian-based operating systems. Viewers, we don't care about this one. I'm going to run 0.2 in today's video, Ayub, just to make it, you know, actually worth it. Review actually, you know, fit in the stream. Otherwise, if we review the whole code, we're probably not going to have time to do the whole thing. But yeah. So, oh, you can donate, my man. You're begging already. Nice. I like that. I like it. You should probably add a Patreon thing in here, man. But anyway, right? Let's actually code this and then see if we can give you some nice feedback. Now, I don't know. Oh. It's fast to compile. I hope so. I really hope so. Now, one of the things I don't already like, Ayub, and I'm not gonna lie here, is that you put all the versions in different directories, right? Which is okay if you don't know how to use Git, but just as a little suggestion here for you, man, if you go into the workplace in the future, it's nice using Git properly, right? So you should probably learn how to use all the features of Git. Specifically, you can do all this stuff here by creating tags, creating feature branches. So for example, you could have just pushed your initial electro bench code here. And then as you change the code, as you create new features for it, you would create these, perhaps you want to work with feature branches. So like you leave your kind of stable code on main or master or whatever. And your feature branches will include all the changes that will take you from that version 0.1 here to 0.2. And then when that work is finished, you can merge it into master again, but then you can tag it. You can use tags in Git here to actually say, this, what you're looking at here is version 0.2. If you want to go to version 0.1, it will be just as simple as like clicking here as well. And it just helps you organize your project a little bit better, because now you've got I'm sure that you've got a lot of duplicated code from 0.1 into 0.2 and also into 0.3, right? So it's not really ideal. So you want to look at, branching and tags in Git, right? So that's what you want to, well, this one is branch versus tags, but you can use them together. And yeah, just Google it, man. There's plenty of tutorials out there, plenty of documentation that's really helpful reading. So do learn that. Now, with that said, let's get into the code. Electro bench. I'm gonna do the second one, the version 2. And you've got CMake here, which is nice. It's good that you took the feedback that I gave you a while back now, right? So I think I first looked at this project with Ayub about, I'm going to say 5 months ago or so. And he wasn't actually using CMake. He was using just bash scripts to do the whole build. And you guys can understand how not flexible that is. So it's good that you took that suggestion, Ayub, and you actually converted this into a CMake project, right? So let's first things first. Let's try and do a configuration here with CMake. Let's see if it's going to work. So could not find glute, right? So this is interesting because I don't have glute. So yeah, I don't have glute on my system, and you are expecting me to have all of these libraries installed on my system, which is fine if you're telling your users to install these libraries through sudo or yam or whatever package manager they have for their systems. But Ayub, this is very important. Oh, you run make install. Yeah, I mean, make install. Okay, so you've got something here. I see. You put it all in the in install. This is fine if you want your users to install system-wide dependencies, though. That's my next point. There are many reasons why I may not be able to do this, especially if I work in a big company with, I don't know, 10 other people on 10 other projects, right? So for example, I may have a different version of Glut installed on my system, and I don't want to override that with the system installation here. Same with CMake, and same with Clang, and same with wget. I guess CMake, Clang, and wget are a little bit different because these are kind of build dependencies, right? So you need them to actually build. But when you look at third-party dependencies such as FreeGlut dev, which you can use to get the OpenGL headers, the glue here that you can use to get OpenGL headers, that becomes a little bit less flexible as well when you do this, right? What I would recommend is that there's different ways of doing this, right? So you can manage your packages in different ways. So for example, one way that I push in the channel quite a lot, so I always tell people who are starting out in C++, look at package managers. Conan version 2 is amazing at the moment. It's probably my favorite package manager for C++. And with like 2 lines of code, you can basically bring in the dependency that you want, wherever it is. So whatever it's defined, if it's on, I mean, as long as it's on Conan Center, right? But that dependency could be on Git or GitLab and it will work. Look at 0.3 code is different than the others. I will do that. Yeah, let's do a 0.3 version and see how good this is. Man, why did I open 0? Oh, I opened the wrong VS Code instance. God, it's just too damn warm in here, guys. It's literally like, I think it's 26 degrees, 25 degrees, which is a lot for the UK. It's a lot for the UK. So how does this differ from the other one? I mean, the code, yeah, I mean, it's still the same here, man. So I tell you what, right? I'm gonna give you some suggestions as well as improving your code. So to do that, I'm gonna create a fork of it, right? And then we can try and Conanify this. And you can see, I just want to show you how easy it is to actually include dependencies with Conan in your project, right? That's what I want to do. And this is very interesting because something I've been doing at work this week is kind of just like rewriting what Conan does. And yeah, I can't stress enough, like just use package managers if you guys can, because it helps out quite a lot. Where is Electrobench there? So I want to fork this. This is a great lesson for people who want to contribute to other people's projects on Git. This is what you do. You create a fork of it. And let's create, let's do the branch master only. And then we're forking it. So forking in Git, for those who don't know, it essentially creates your own copy of someone's repository in your account. So essentially you can just use your fork to make changes to the code. And then once you're done with those changes, you can go back to the original repository and then like create a pull request, right? So you can create a request on the destination repository where you say, do you guys want to take the changes I did here? Please review it and accept it. That's what a pull request is essentially. And it's the way that you contribute to people's code, right? So let's remove Electrobench. Is a directory, that's fine. Let's get our own version of Electrobench now, and let's start working out. So I am basically let's modify version 0.3, right? That's your most up-to-date code, isn't it, Ayub? So I'm gonna copy a file from 1, 2, 3. I'm going to copy a file from maybe this one here. Okay, so we've got a Conan file now. Now, Conan file is basically all you need, right? So what I'm going to do here is I'm going to look at the dependencies that you have, the third-party dependencies that you have in here, and I'm going to bring them to Conan. So you've got glut. Glut is available on Conan for sure. Let's go to Conan.io and go on Conan Center. And you got free glut. Is it glut or free glut? Yeah, it's free glut. So free glut free, that we're going to bring that one in. What else do we have here? You've also got glue. So let's bring that in. And I think that's it, right? That's all of the actual third-party dependencies that you have in here, which is good. Am I missing something else? Let's take a look. So you've got glut, OpenGL, required. I mean, I believe that's brought in with, I mean, I believe that's just a system thing, right? Are you actually linking against OpenGL targets? OpenGL include directories. Yeah, these come from glue here. Free glut has dependencies. You can run it. Yeah, we can run it. I just want to bring in those things. Now, what headers are you getting from OpenGL that you don't normally get with glue here? OpenGL system. Yeah, we can do that. So you're actually, I guess this is a wrap on OpenGL's system headers that you get. Yeah, okay, we can do that. So in essence, we will still get the users to actually install OpenGL on the machines. I don't think they have a way around that. They just have to have the drivers, right? But OpenGL system will basically find those headers for you from the user systems. So cross-platform virtual Conan package for OpenGL support. So yeah, let's do all of this, right? So we've got free glut in here. Let's bring that in. So we are gonna put that into our Conan file, free glut, OpenGL. And glue in here, right? So let's sort this. We sorted, and we got the generators, that's fine. So, you know, to bring the dependencies in with Conan, this is all you have to do. Now, all you have to do is just do a Conan install, and we're gonna put it under Conan debug. I'm gonna just build in debug this time, just because I want to be able to step through the code and give you some feedback as well, Ayub. By the way, if you guys haven't yet liked the video, please like the video, because YouTube just helps me out quite a lot if you guys actually do like the video. And yeah, say hi on the comment as well if you're just watching it. I want to see, I want to hear it from you guys. Okay, so a lot of warnings here. Now, it'll be very interesting if one of these dependencies don't actually build in Conan, because these are very, very simple dependencies. But yeah. By the way, Ayub, if you haven't noticed yet, what Conan is doing here is grabbing all the source code from these dependencies and then building it in your machine. And it stores it in a very specific location that doesn't interfere with your system's like glue version or free glut versions that you've installed. So it's way more containerized in the sense that you can, yeah, you're not going to interfere with anything in your system. That's probably one of the main advantages of using a proper package manager, other than just kind of relying on the user to install things on the system, right? But anyway, so we've done that, and now all we have to do here is, okay, we have to do something like this, right? So we have to go into settings.json and tell CMake that we want to include some additional configure arguments here. And the one we actually have to add for this to work here, for Conan to work with CMake out of the box, you need to do CMake module path. And then that will be workspace folder. Temi Femi, hello dude. How's it going, man? Welcome to the stream, dude. First time here, right? Unless you've got a different account and I've not made that connection, yeah. So workspace folder, and then we do Conan debug. Or is it Conan deb? It's Conan deb. Jesus Christ, right. I can't spell today. Conan/deb. That's all we need to do. I use Vim to edit. Well done. Very nice. Well, let's see if we can configure this now. So we've got the project. Let's see if we can do a CMake configure. It's picking up my compiler GCC here. So FreeGlut did not find that. So could not find a package configuration with file provided by XKB common. Where is XKB coming from? First of all, these might change actually. I think these will change. So let's take a look. So the name of the actual CMake targets will change, I think. And none of these have any like actual examples. That's fine. But we can find them. We can find them by just like scouting the Conan the Conan directory here and seeing what specialties have been brought by Conan. So it's just glut, it's just glue, and it's just OpenGL, right? Find FreeGlut, yeah. Did you mean to do FreeGlut in here as well, though? Let's see if FreeGlut is going to work. So FreeGlut config is not a thing, but it should be. It's right here. It's just right here. Is it because we need to change? Is it variant? Yeah, select variant. There you go. Add glue. Yeah, what you had here was glut before. And glut does exist, it's right here. But then it says we don't have XKB, and I'm not entirely sure where this comes from, to be honest with you. Which is a dependency of what? CMake error at whatever, CMake find dependencies. So you found glut. I do wonder if this is something that's cascading from. Oh, it's find glut. There you go. I'm gonna have to open the window. Sorry, guys. It's just too damn hot in here. So you might listen to train noises, and I do apologize for that. Yeah, every now and then when you do something with Conan, you might have to debug it a little bit. So we couldn't find this, for example, but this is something that should have been brought in by FreeGlut as a dependency here. So let's see. Maybe we can add that directly. Let's put Conan here, because this is a Conan issue. Look at the XKB common. Yeah, I just wanted to see if there's like an issue with the actual recipe, but we can do that here as well. So XKB common. There you go. So we're just gonna do this directly. It's interesting that FreeGlut actually depends on it, but we haven't had that brought in by Conan, which is interesting. So there's some issues with the recipe sometimes. But anyway, let's see if we can find that. So we've installed everything. Can we reconfigure and work now? Now we need Mesa. Jesus Christ. Could not find package configuration provided by Mesa. Mesa glue. That's fine. We're also going to change that and put it in. I don't understand why these packages, like, they are definitely dependencies to, what is it? To FreeGlut, but why are they not being brought in by Conan? What the hell? Undo that. There you go. Now I don't want to have to do this for every missing dependency, but it seems like we're going to have to. It shouldn't take too long anyway. Let's delete the cache and reconfigure. Like what now? Mesa glue the... It's definitely there, isn't it? It is definitely there. Yeah, Mesa glue config is oh, right, I see. Maybe we can put this directly onto the CMake lists. Let's see. Now it's interesting that it's not actually finding the file. The Mesa glue is here. Mesa glue config right there. And we've got debug on. By not providing finding Mesa glue in the CMake module path, this project has asked CMake to find package configuration provided by Mesa glue, but CMake did not find one. Like, it's right here. just find it. It's not that difficult. And we've got the right directory as well. CMake module path. Unless I've misspelled something. Now this looks right. This looks absolutely right. Why is this not finding the file though? So copy path, where is it? Yeah, I still don't understand why CMake is not finding the file. Because it's looking for Mesa glue config. And I can definitely, most likely, see Mesa glue config here. Which is interesting, isn't it? Also, can we select a preset? In Conan. Look up Mesa and glue in Conan. Yeah, it's already here, man. We've done that. So we've got Mesa and glue here on the list. And it generates the find files for us. But the find stuff doesn't find it. So the find package doesn't find it. Which isn't ideal, because I thought this should just work now, right? Do we have to like reinstall it? So there you go, find package, free glut, Mesa glue. And that's what I want, basically. This is what I want. No Mesa dev alone and glue alone. Yeah, but those will not be the let's see if this works. I'm just gonna do what Conan told me to. No, I didn't find a single one of them. What the hell? Kind of makes me feel that this, like the CMake module path is not being passed in. And I think I'm right, and I think I'm completely right. I can't see it. So executing command CMake, oh no, it is here. CMake module path. Electrobench Conan debug, which is here. Yeah, I have no idea what's going on. So we're probably going to move on before we fix this. And of course I've got the right CMake tool chain depths, right? Let's do it through the CMake toolchain instead. Maybe that's the problem. Right, so in the settings.json, we can do something like the CMake toolchain file and add the workspace folder, Conan deb. There is a Conan toolchain there. Let's try through this instead. I think we might have a little bit more luck now. So hello Slim, how's it going, man? We're trying to do some reviewing here if we can get this to compile. Select a kit, right? Let's go for Clang 14, right, or Clang 17. Ooh. Wait, since when do we have all these compilers in there? Jesus, I was not aware of that. Well, let's reconfigure. So now we've got Clang 17 and things build, which is fine. There you go. All of that just to get Conan installed. But yeah, point is, do use Conan. You might have to debug it for 10 minutes, but it's worth doing it anyway, right? Now Ayub, we're gonna build this and it's not gonna work. That's fine. We're just gonna, there you go. We're gonna change some headers here. So include, yes. Now this is the interesting stuff. This is where we change our CMake a little bit to actually include the targets that we've created here, right? So if I do a reconfigure, hopefully Conan will show me which targets you actually have to link against your libraries, right? So for example, wherever you have this here, this will change, right? So we need to use the targets instead. So you want the OpenGL libraries, I get that. You want the glut libraries as well. And you want the glue libraries, right? Now, which ones are those? We need... And also, before we go anywhere else, right? We should be able to get rid of some stuff here. I'm not sure we need these anymore. So this one here and this one here. I'm just not sure. Because I think what we had before was that actually CMake wasn't finding everything. But now that it's actually using the Conan dependencies, it shouldn't complain anymore. It just shouldn't. There you go. See? Because Conan brought everything up to us here. Automatically. But, so we want free glut static. We want glue as well. Let's find those. So declared glue, glue s. Conan target declared glue, right? So that's what we have to do. So we want glue, first of all. I'm gonna be using SL expected rather than STD expected. I still couldn't migrate to C++ 23. Ah, all right. So you're gonna be using the GSL one. Yeah, does GSL have expected? I didn't know about that. I remember I was speaking about GSL in the last stream, actually. It was a very nice little refresher for me because I hadn't used GSL for ages. But in my previous work, where we had like, I think we're on C++ 14 and we couldn't go to 17 for some reason, we used GSL for a bunch of stuff because it's just nice. So it gives you some of the newer structures. But anyway, so we want OpenGL. I guess that will be libgl. But we also want glue, right? Oh, yeah, we've got glue libraries here already, so we don't need that anymore. We want FreeGlut. That's the one. So we want also OpenGL here. And whichever FreeGlut library that we had. Let me just find that, because it's very difficult to find it. FreeGlut static, that's the one. Right, in theory, I think this is what we're gonna need here. Right? Let's try and build this now. You're gonna still see some issues here with OpenGL, hopefully. Oh no, it did build. It built successfully. For some reason we can't, IntelliSense says that we can't find this. But yeah. Now let's actually look at the code. So all of this, we spent like 15 minutes actually Conanifying a project, Ayub. So it's a lot easier for you to actually include whatever third-party dependencies you want. And it should work in, whoever is running this, as long as they have Conan, right? Which isn't a big of an ask today. It's just a package manager. So I'll tell you what, Ayub, I'm going to push this suggestion to my branch, and then I'll create a PR for your project so you can improve it a little bit, right? So let's do that. So git add this, and we did change the CMake lists. What else did we change? Oh, we added some untracked files as well, right? So we added the Conan file. And that is it, right? And obviously we want to kind of change the README as well. So you'd have like building instructions or something. Command on your machine. Oh, can't spell it. Put readme in root there. Yeah. Ooh. You have a readme in root there, but that's not for this, right? Yeah, we can do that. What the hell? Okay, good. Yeah, we'll delete that file. Let's do the following. So we're gonna cat electrobench 0.3 readme and put it in the readme.md here. Okay, and now we're gonna remove this one here. Okay, and now we should be able to have readme.md there. At the very end, we've got build instructions for every 0.3, right? And this is the interesting part, because I'm gonna actually have to get the thing that I'm asking your users to run and put it here. Except it doesn't work, does it? Really? There you go. I'm just gonna give you some sort of like very basic instruction here to build the project, Ayub, but you can like make this better in the future. To configure CMake, don't forget to pass CMake what? Do we actually have to scale this? That's amazing. I didn't know that. Something like this. So CMake dot and it's the CMake that is it, right? So we've got those. Now it all builds. Does it run though? That's the point. That's the point of this, is to actually make sure that it runs. So I'm gonna quickly scout this, Ayub. I don't think you're doing anything to hack me or anything, right? So this is something people or streamers don't normally do. Just run people's code. You are opening some files here though. Reads the contents of the text file. What are you using this for? Ah, so you're reading the fragment shaders. That's cool. So you've got fragment shaders here, vertex shaders and fragment shaders. So your vertex shader looks pretty slim, and that's normal. It probably just passes on the stuff to the fragment shader, right? And then you do a bunch of stuff, which is nice. I like this. I don't understand some of this yet, but we will get to it. Can I set a syntax here? Set syntax. Syntax? How do you set syntax with VS Code? Anyway. I'm just going to quickly scout this. So in your main file, in your main function, you're just creating a window, clearing the color, swapping the buffers there, swap interval, sorry. Glut main loop. So glut is the one you have like callbacks, right? I have a make file, add it there, put readme in root. I don't know what you mean by you have a make file. Oh, add it there. Okay, yeah, I'll add it to the make file. That's right. But that's the thing, with CMake, you shouldn't really need the make file. So CMake replaces the make file, you see? So it's good for you not to rely on the CMake. The change I made here just makes your project rely completely on Conan and CMake instead of the make file, right? So the user doesn't have to install anything through the make file. They won't have any system installations. So this is the point of this here. So, and that's the suggestion I'm going to give you. So try and stick to CMake whenever you can, because make files aren't very flexible. Like it works on Linux, but if you try and build the same project on Windows, for example, it won't work because that make file just won't work, right? It just, it just won't. But with CMake, it works. So now you automatically got your project compiling on Linux, on Windows as well. That's the good thing about it. Yeah, I'm fine running this. Let's take a look, right? So if we now go into build, cd electrobench 0 version 3, and then we go into build. Conan is cross-platform. Yes, Conan's Python. Conan is written in Python, so it's very cross-platform. Yeah. Now error, no display available in function. FG platform initialize base. FG platform. Free glitch platform initialize base. That's interesting, isn't it? Does it really not find my... It's because I'm running on WSL. So the thing is, it probably doesn't find my display because of that. But if we Google this, we should be able to actually figure out here. But let me just finish what I was doing before I forget, which is actually pushing this to your project, right? So YouTube. So I'm gonna close the window. There's some like coughing outside. I'm not sure if you guys can hear that. We changed the README, yes. What else did we do? Have we changed Conan? No. Yeah, okay. Conanify project. Run build electro bench, the root there, so it finds the shader object files. Okay, I'll try that in a second. Everything up to date. All right, Ayub, first suggestion is there. Now I'm just gonna raise a PR on your thing, and then you can do whatever you want with it. You don't have to merge it into your project. You know, just look at it and make sure that you understand the changes and you understand why this can be good for you in the future, especially when you have projects that have a lot of third-party dependencies. Conan is always good. Conan is always a good thing, right? And you see, only like what, 38 lines. It's not even that much, right? Not even that much code. Now you say that I have to run build script. There is a build here. Run build electro bench. The root there, so it finds the shader. Now we don't have that. Oh yeah, we do have build here. I'll check out tomorrow and modify it. Yeah, sounds good, man. Yeah, so I can't run a project because we get this, right? So let's actually see if we get any errors. If we get any help with Google. Because we might be able to. As simple as that. And this is definitely a free glut error. It just looks like one. So we've got GL and glut. Is that included in the right order? There is something. GL and glut. So is v3 supposed to run? Ayub, that's my question here. Does it actually run? I'm gonna take this off because it's too hot now. But anyway, it doesn't need to run for me to be able to actually review your code, right? We can just do a quick review. So we've already reviewed your project description on GitHub. We have already spoken a little bit about how you can Conanify this project, and we've actually done that work and pushed it as a PR, so that should be there. So now let's actually do, what we're here to do. Take a look at the code and make sure it makes sense. Add WSL to the search query. That is true, yeah, we can add WSL. But I don't think this is the problem because I can run other OpenGL applications here, man. It's definitely not the problem. OpenGL is not the problem. Sorry, WSL is not the problem. So I'm not gonna try and pursue this because I'll do this some other day. Right. So let's look at main. Let's look at main because that's the starting point of every program. We should be able to understand it, right? So initializing glut, we do a glut init here, which takes the arguments, and then we initialize the display mode. Now I'm pretty sure this is what's actually failing, but we can look at this in more detail right now. So if we add a configuration here for C++ launch, and this is a program name. Ooh, deleted a little bit too much there. So we're going to go into build an electro bench, right? That is it. Now, let's see. Yeah, so this function glut init fails. So glut init is the one that actually fails. Am I meant to pass something to it? That is a question. I don't think so, right? I think it's just meant to work. Yeah, internal error, no display available. I mean, I can set my display to 1. So I can set my display to 0 here, but I'm not sure it'll make a difference. We can try though. Environment, right here. Ooh. Let's try that. Yep, no, it still doesn't fix it. I have seen this issue before though, and it fails to find the display in WSL. Should it not be .0? Oh, you're correct. Yeah, I'm just doing it right. Its value is probably this launch terminal. Yeah, you are correct. I was adding the wrong one. God bless my viewers. God bless my viewers for being here. What would I be without you guys? Because in Linux I need display -0. Yeah, that didn't fix it. What about just this? Just 0. Nope. Yeah. Yeah, Jean, like, I have seen this before. I fixed this before, I can't remember how. But now it's back, and I have no idea. Display 0 value. Oh wait, display 0, okay. So the it's saying that I should actually have the variable called this and the value empty. So that's interesting. Let's have a look. That doesn't make sense. Is this even a valid like syntax in Bash for Bash variables? It can't be. No, yeah. Maybe we spend another 5 minutes just trying to fix this, just so we can run the program. Otherwise, it's going to be quite boring just reviewing it without being able to run the thing. So yeah. Yeah, see, the thing is, I know OpenGL works on WSL. Does it run if directly in WSL? I joined, so not sure. Yeah, a good question. No, it doesn't. It still doesn't run. So if I go to the build directory and then just do it from here, we still get that. So it's definitely a problem with the program. Maybe Ayub is not setting things correctly in FreeGlutch. But what is interesting is that I've got some OpenGL projects here. Let me see which one actually sounds good. I can't remember which ones they are now. That just have like a 65K. Yeah, so this this emulator that we've created here does run, and it has OpenGL in it, and it's not WSL that's the issue. I think it's something in the actual setup code, but yeah, I'm not going to bother too much about finding the issue though. It works on my PC. Yeah, famous last words, man. It may work on your PC, but it doesn't guarantee that it's going to work on other PCs. But the thing is, I don't know what could be wrong, because like all you're doing here is initializing glut, and you don't do anything else before that, which is very interesting indeed. So that's an interesting one. Now there is something funny about including glut, right? GL. We have glue, we have GL here. Does it have to be before? Are you missing that by any chance? Yeah, GL is included before glue. Yeah, that's the one. There's always been this problem of including GL before glue. Is that does that make any differences? No, it doesn't. No, that is a bummer. That is a bummer. Free glut std, free glut. What is this header? I don't even know what that one does. Yeah, I don't know how you, but I don't think we're going to be able to run this today. So we're just going to go to the review, man. I'm sorry, I tried. We tried to run the project. So all of this, right? First piece of advice. I mean, this is nice. Your function is actually very small, right? You could put all of this here into like a function, right? So you can just create a unit, a separate function, and name it something like, I don't know, initialize window. This is all it's doing, right? Yeah. This is what we could do. Initialize window, and it takes the argc and argv, right? I always like doing something like this when you have like a complicated library such as OpenGL, just because, you know, for someone who doesn't know OpenGL, they're looking at this for the first time, right? And they're thinking, what the hell is this doing? Like, but if you put it inside a function that only has like, you know, a few lines of code, or a few lines of boilerplate code, in fact, and you name it something kind of reasonable, like initialize window, they will look at that function and know what it is because it says it in the name. So yeah, I just recommend whenever you're doing something that's like very specific to a library, very specific to a particular algorithm, try and kind of segregate some of the complicated functionality out into smaller functions and just naming them correctly. There are certain times you don't want to do that. For example, you don't really want to put code that's running kind of like a tight loop in a very sort of performant program outside that for loop into a function, because that may or may not add some performance issues. But in this case here, it's just something that runs once. There is no kind of disadvantages to just separating this and putting it into a function somewhere else, right? So my next point here is use anonymous namespaces for that kind of stuff. So for example, if you were to create that function, you can come down here and create a namespace in C++ and just not name it. Just not name it. This is called an anonymous namespace in C++. And basically every function that you put in here, it tells the user straight away that these functions or this code that's in the anonymous namespace are only used in this file. They are not allowed to be used in other compilation units because you can't get access to it. This is essentially a namespace with a random name that the compiler gives to it. So there is no physical way you can get the code in here in other C++ files, which is good because it may hint to the compiler that you can kind of like more aggressively optimize things. You know, if you really want to guarantee that, you should probably use inline. But yeah, this is a good contestant for this now, right? So if we were to kind of do that, if we were to just copy here, paste that code here, call it something like void initialize window argc, which is a int argc, and then a car star argv here, and there you go. And down there you can kind of call that function. You can just call it here, right? So, oh, actually 29. And there you go. I mean, it's all the boilerplate code is here, and if I want to understand this, I can go and read it. But if I just want to like skip over it, I kind of know what this function is doing because the name says it. And it's, yeah, it's not a problem. By the way, please like the video if you guys can. If you're new to the stream here, helps me out quite a lot. Right, so we've done the boilerplate code. There's nothing wrong with that. I'm pretty sure that you just kind of got it from a tutorial, which is good. You know, the thing with boilerplate code, especially with OpenGL, is that it's like you can understand it if you want, but there's also no point in understanding every function call for initializing a window, because it's always going to be kind of like the same code. And knowing what the overall code does is good, but yeah, don't worry too much. I'll give you screenshots of the bench on Discord. Yes, please give me screenshots, and I can at least show it to people what it does. So yeah, because we're not going to be able to run it here, it seems. After that, we clear the screen and we initialize glue, and we initialize glxu in it. I've never really used glx stuff, to be honest, so I don't really know too much what this does, but yeah, I guess it's time to find out. What is glxe? What is glxe? What? I've never actually seen that. Do you need this? What is this doing? glxew. Go on, for my OpenGL programmers, what is glxew? Use it for disabling vsync. Ah, okay. So the GL extension Wrangler library, yeah, this is glue. But what is the X standing for? Does it say it in the file? No, it's just the license stuff. GLX versus GLX EU. I'm still having trouble on running VirtualBox before this gets sidetracked. Okay. Oh, it's X11 only GL. Okay, cool. Yeah, I never really used that header, so that's why I'm wondering what it does. Wikipedia GLX. Let's take a look at that. A juicy Wikipedia page. Thank you for the links. GLX initialization for OpenGL extension to the X window system is an extension to the X window system protocol, providing interface between OpenGL and the X window system. Yeah, so it's X11 stuff, right, from the looks of it. It enables programs wishing to use OpenGL to do so within a window provided by X window system. GLX distinguishes two states. Okay. Yeah, but my question is, like, if you have FreeGlutch, which kind of creates the window for you, right? Yeah, I'm pretty sure like it may use X11 internally. Or is it just the context? You know, yeah, it creates windows as well. So if you have, and this is a piece of, this is like a more of a question on the approach as opposed to the code Ayub. So if you're using FreeGlutch already to create a window for you, why do you need GLX in here? Because this is inherently going to break your code. Like this only really works on Windows. Like you can't get X11 on Windows. So yeah, I mean, by including this header and using the functions in it, it just seems to me that you will take a portion of your of the platforms that you can build for and then just like throw it away. You're basically saying you don't want to build on Windows here. So this is more of an approach question and something that you should probably think about, because yeah, if you want to make your code a little bit more portable, maybe think about removing that dependency. And that's just my opinion. You might, you might not agree with that, but that's fine. If you just want to keep it on Windows, it's fine. Sorry, if you just want to keep building for Linux, it's fine. But anyway, glue init, glx init, glx swap interval mazer. So you disable vsync. If glue is supported, version 2. Yeah, I believe for Windows you would use WGL. I'm not super familiar with this level of OpenGL programming, since I would usually use SDL and GLFW. Yeah, I mean that's experience enough, but yeah. So the main takeaway is that we're really using a freeglut to create the windows at the top here, and then we immediately call glx to disable vsync. There must be a different way you can use to disable vsync with OpenGL as well without having to use glx though. It sounds like a fairly common thing to do, but just think about those things. So we we set the interval. See, this is like something specific to glx, so I don't really understand this very well. I'm going to skip over it. We see if OpenGL 2.0 is supported, and we init. What is init? Oh, we have a function called init already. That's fine. Initializes the application, compiles the shaders, and set attributes, and loads the object file. Let's have a look at this. So you have the car star, vertex, VS. Okay, first thing here. First of all, sort out all the sort out all the indentation, my man. This is indented with 2 and then indented with 4. There you go. We need the same level of indentation everywhere, please. That's just annoying me. It shouldn't be, but it is. I don't want to be that person. But yeah, car star here. I mean, I much prefer to use strings, but if you must use car stars, we'll see about that in a second. Yeah, just initialize it with no pointer instead of no. And also try and do 1 per line, just makes things a bit clearer. Ooh, fragment shader. So you create an ID for the vertex and the fragment shader, I believe, right? Yeah, vertex shader and fragment shader. You don't do any error handling though. So these functions may actually return an error for you. So for example, create shader, I believe will always return. Wait, let's check docs.gl. So for those trying to learn OpenGL, docs.gl is the website you need, guys. Just check it out. So if we have gl create shader, and you are using version 3 supposedly, I don't know, because you're actually checking for version 2. So I don't understand it yet, Ayub. You said it should use version 3, but you're checking for version 2. But anyway, that returns a GLU int, and if you look at the return type here, it should tell you exactly what it could return here. So errors, this function returns 0 if an error occurs creating the object file. So you're missing the checks here, right? You are definitely missing those checks. So I use 2.0 in 0.3. Ah, okay, I see. But anyway, I think this should still be the same, all right? So it should still return. There you go. It should still return 0 here. So my point is, do check if you don't have a 0 ID, because if that happened, then you kind of have a problem there. And you know what is actually very good, Ayub? So if this is just used for development, I mean, yeah, you could use an expect here from GSL. So expect the vert is not equals to 0. That's basically what you have to do. But this is actually a runtime problem, right? So you do want to check that var is not equals to 0 with an if statement. And if it is, we should probably kind of like log something here, log something, and then exit or panic, right? That's all you have to do here, my man. And of course, you have to do the same thing for vert here. So you probably, for the fragment shader. So fragment is not, if fragment is equals to 0, you want to log something and then exit. In the same way as this one here is, except I got the logic a little bit wrong. It should really be equals 0. How can we do that? How can we panic in C++? Ooh, there's std terminate, right? I believe that's it, so it doesn't take anything. So we can just terminate here. And which header is this in? Is an exception. Okay, so I don't think you need to include anything there, it just exists. So at this point here, you kind of know that you can proceed and you can continue with the ID that you got, right? So we read the entire text file into VS. What does that return to us? That returns a character star. Right. Ayub, I'm going to suggest something that may help you, right? So char stars are good. I mean, man, I still prefer using strings in this particular case here. Now, why would you want to use strings instead of char stars in this case? First of all, is the concept of ownership, right? Because when you see a char star in code, you kind of wonder to yourself, is this actually a pointer to a string, or is this a pointer to an array of characters? And if so, who owns that data? But if you do strings here, you kind of know that the object owns it. Char is unsafe. Yeah, mostly, yeah. It depends on how you're using it. In this case here, it might be because, yeah. And, you know, if you're actually, yeah, you're doing mallocs and all sorts of like interesting stuff here, dude. So definitely, this is the least of your problems here, using a char versus string. I'm gonna be honest. So first of all, let's actually change it to a string, right? And the file name, let's also put this to a const string here, right? And let's actually convert this very, very unsafe function into something that's a little bit safer and easier to read, right? You're using the file pointer, or the file pointer, sorry, the file header here, the C file stuff. It actually comes from IO stream. No, not IO stream. Where are you cascading that from? So C time. Where is the file pointer coming from? Anyway, what you want to do is you want to probably include f stream there and use the file streams. In this case, you know, these fragment shaders, these vertex shaders that you have, they're so tiny that it doesn't matter if, even if you do the slowest file reading C++, it's still going to take you like a split second. I believe in this case, the char star is an array of characters since it reads from a file and passed to yeah, maybe string view or spam. Yeah, but also that's the thing. This is all just a string. He's reading a string here. So returning it as a string is fine. There is no problem with that at all. After all, that's what string is. String is basically a basic string view, or sorry, basic string of character. And if you actually look into it, it's just basically a vector of characters. So, but yeah, let's try and actually see what you're trying to do. So you create a file pointer here. You create a content pointer, which initializes as null. And then you say if the file name isn't null, you open the file. So this could immediately change to something like, you know, it's not going to be null in this case, but it can be something like, you know, file name isn't empty, right? If it isn't empty, then you can open the stuff, right? And you open the file here, you do an f open that just opens the file and returns the pointer to you. And then you f close at the end. Isn't std string now guaranteed to be null terminated? It's always been guaranteed to be null terminated, yeah. but it doesn't matter for vertex shaders, fragment shaders. Yeah, that's correct here. So yeah, I mean, this is interesting, Ayub. So I understand. Like, I'm gonna show you how to read a file in C++, right? Is it iStream iterator, the header? I keep forgetting which one it is. iStream both iterator, that's the one. Which comes from which header? Come on, iterator header. I'm going to show you the most elegant way of doing it. So what you really want to do is something like you create a file, auto file, import file stream, and then you're going to do file name here. Or in fact, we can just do that. That will do as well. std iStream both iterator. Now, how do we read? There was a particular very interesting way of reading with an iStream both iterator. I keep forgetting about it, but I recommend it because it's 2 lines of code. Got to go. I need to sleep early. Show me highlights tomorrow on Discord. See ya. Yeah, no worries, man. I'll definitely show you the highlights tomorrow. Don't worry about it. I'll just review your entire code. There you go. So with 2 lines of code, you can read the entire file into a string, just like that. So we already have in, and there we go, file. And we just return this. But basically, that's what we do. Ooh, that's what we do. We just return that. And that is it. That's basically it. You read the entire file now in C++. You don't need all this stuff here. Definitely don't need any of that. You definitely don't need any of this. And that is it, right? In here, I guess you can return just an empty string if you must return something in here. But yeah. Oh, that is cool. I haven't seen this method. Yeah, it's a weird one to understand. So for fstream, as the name implies, is a file stream, right? So it's an input file. It's an input output file stream, which means you can use the operator, file, whatever, those stream operators in C++. An iStream buff iterator is basically an iterator type in C++. You say which type you want to iterate over. That will just go over your stream, read each character, one by one, and return the the overall collection. That's how this works, right? It's not the fastest method. It's definitely not the fastest method by a lot. If you benchmark this, it's actually quite slow compared to other methods. But for reading files like this, where you only have say you had 1,000 lines of code, it's still going to be really, really fast. It doesn't matter. And it turns your functions into something very, very small. So yeah. But anyway, so now this is definitely going to fail. 100% going to fail, in fact. So we say now that we have to change, we have to change these things here. Another thing I was going to say to him, but he's left now, is always create your variables whenever they are used. Don't declare your variables at the top here and only use them down there. In fact, we can do something like this now. Ooh. There you go. We're slowly turning things a little bit better. So const car start, what are you doing, Ayub? What are you doing here? So let's see if I understand this. So he casts the car star pointer to a const car star. Oh, I see what he's doing. It's because he simply just wanted to have the data here, right? So the shader source, which is fine. This function basically reads the shader source, so the actual source code that you've loaded into memory. So something like, let me just bring it back here in OpenGL, the actual shader code, and it will, you know, store it into the vertex ID that you've created before. That's all it does. The null at the end, well, actually, the last parameter here at the end specifies the number of bytes for the data. But if you leave it as null, it's just gonna run it until it finds a null pointer, which is, sorry, a 0 byte at the end, which string does have. So this whole thing, you know, we can remove that as well, make it even easier. I think here you can just do, yeah, exactly. So we can just do something like vs.data, and we can also have fs.data here, and we can leave it as null. We can leave it as null because these strings are guaranteed to be null terminated, right? So something like that. And then we free. See, we don't need free. We don't need frees in C++. If you're using it, you're doing it wrong. If you're using memmalloc, or sorry, yeah, what was it doing before? If you're using free, that means you've allocated memory manually before, which in most cases you don't need it. There are certain cases where you may need to allocate data, especially for like very tight algorithms that require performance and you just want to do a raw memory allocation. But in 99.9998% of the cases, you don't need to do that stuff manually. Just don't do it. Right, so we compile the shader. Now, compiling shaders may return something, right? I believe it probably does. No, it's a void. Yeah, interesting. I think it might be safer to use CString just to ensure the null termination instead. CString and data will give you the same stuff, by the way. They're literally just giving you a pointer to the data inside. Which in this case, because string is a basic string of character, it's just a const char star. And CString is the same thing, but yeah, we can do that. Why not? It will be the you're accessing the same data, if it makes sense. So .data and .cstring will give you the same stuff. So print shader info log. I like this function. Now, yeah, see, he's got a malloc here. What is he actually doing? Info log length. He's allocating. So what's infolog? Infolog is a char star. Again, always declare your variables where you use them, not at the top. It makes it a bit easier for me to just look around the code without having to like scroll up and down, and it just annoys me. But anyway, so he's allocating a string here. Yeah, I mean, I'm not opposed to this, you see. I'm really not opposed to this because I believe that GL get shader info log actually does need a pointer to a buffer here, and you kind of need to do something like this anyway. Yes, you could possibly do it with an array here. Let's do that, right? Let's include an array here. So let's first of all let's use Vim to fucking sort all of this. So there you go. Include array. Go back here, so we create an std array. Wait, what? Ah, okay, no, we can't do an array. We can't do an array in this case because he's actually getting the string dynamically. So he's allocating things, yeah. Would this not be asking for undefined behavior instead of new replacement, new array? Placement, new array. I'm afraid I don't understand the question, John. Malloc doesn't instantiate an object with lifetime. Yeah, no, it doesn't. It doesn't. So whenever you do a malloc, you have to remember to free it. That's the catch, right? That is the catch. But what I was gonna do is I was actually gonna. Yeah, I mean, we can kind of hack an array into this, right? So we can do something like an array of character. And we do something like const expr std size t here, max log length. and that would be something. That would be something like I don't know, like 100, I'd say. Yeah, we can do something like this, and this is going to be 0 initialized. So log buffer is always going to have like an array. It's always going to be a buffer of 100 bytes. And yeah, I want to see if this function actually. Yeah, it takes the buffer size, which is good. It takes the buffer size, so it will never write more than the buffer size. So we have the object here, that's fine. Characters written. Again, we're only using this down here, so let's just move that. Remove this. Info log length. So if we do have a log, okay, yeah, that makes sense. Oh, what I meant to do was this. Yeah, so we query to OpenGL whether or not we have a log for the shader, because this will give us a log length, right, of something more than 0, hopefully. And if we do have a message waiting for us, we are gonna get the characters. Yeah, I'm pretty much just saying we should use new instead of malloc, but may just be a nit since this is a character. Yeah, I mean, new and malloc kind of the same thing anyway. New is just the C++ way of doing it. Malloc is just, I guess, the C way of doing it. Neither of them is great. If you're doing something like this, you can just avoid it overall and not having to delete or free your memory. That's what we're doing here. We're just converting this code. So info log. So we're going to delete that. And yeah, max log length object. Where does the buffer actually go? Here, right? So we can pass in the log buffer dot data in this case. And he's doing a printf. That's fine. I'm not going to complain. But yeah, we've completely removed the use of malloc, and we used array instead, as Jean suggested. And this should basically tie the lifetime of the buffer to the end of the function. So there's no way you can forget to delete this, and there's no way you can leak data. Now, this is definitely not going to compile, and we're going to find out why. It's because of the changes we made before. So here we say we cannot initialize a parameter of type const gl char const with an r value. Ooh, what? With what? What is this taken? So this is taking a pointer to a pointer. Ah, okay, because this is a count 1. Yeah. Yeah, so this is actually taking an array of vertex shaders. Okay, that makes sense. But we can just do this. Let's see that now. Right? We cannot take the address of an R value of type const char star. What? Why is it an R value? If we do data now, does it work? Oh, that is interesting though, isn't it? Why does this hate string so much? So create shaders. I'm going to zoom in so you guys can see a little bit better here. By the way, if you guys are new to the stream, please like the video. It does help me out quite a lot. Much love. So where are the arguments that this takes? Oh no, this is just create shader. We want compile shader, right? Compile shader, that's the one. ESL2. So, right. Parameters. Specify the shader object to be compiled. Oh no, shader source. I'm looking at the wrong function entirely. There you go. Get shader source, set shader source. This one here. Oh, printf assumes no terminated again. Does info log return a no string? Maybe just needs a comment. Yeah, good. Good that you've asked. So when you create an array like this and you do it like this, all the elements are 0 initialized. So this is 0, 0, 0s like everywhere, if you see what I mean. This function here will write to the beginning of the buffer, to the end of it. I'm not sure if it's 0 terminated. If it's not 0 terminated, it's going to be, you know, probably 0 terminated anyway. Which is, yeah, good point, because if this has size, if this returns a log of size 100 exactly, then we're not going to have a no termination, which could be a past pointer bug or something. Get shader info log. Let's take a look at that. I'm interested now. Specifies an array of characters that is used to return the information log. This returns the information log for the specified shader object. The information log for a shader object is modified when the shader is compiled. The string that is returned will be no terminated. Yeah. So you are, yeah, you're right. It's no terminated, so we don't have to worry about it. Because that could be a bug if it wasn't. Right, yeah, so shader source, that's the one we're... docs.gl, again. And I was looking at this, right? So the const string specifies an array of pointers of strings containing the source code to be loaded into the shader. And if we look at the example here, so shader source, vertex shader source. Okay, we don't actually have the type of it here. We can't take the address of a... Okay, yeah. I mean, that's fine. We can kind of hack it in. So we can just say that we want a const car start, and that is the... just so we can take the address of it. So vertex shader.c string, or data, in fact. And this is literally just a pointer. I understand what Ayub was doing before, and it kind of makes sense now. But we can just do this now. Should be a little bit happier now, hopefully. Because now we can take the pointer of it, because this is actually a variable. So we can take the pointer to a variable that stores a pointer. And just like that, we've removed all the ugly stuff that was in here regarding mallocing and freeing. There's a lot more stuff. Maybe we should take a look at it here. So what is he actually doing? So he's compiling the shaders, setting the shader source, which doesn't return anything, right? Compiling this shader source doesn't actually return anything either. It's printing the shader log info, which I guess just says what has been compiled and if it succeeded or not. I'm not too sure. He creates a shader program. He attaches the vertex, the compiled vertex, the vertex shader and the fragment shader to the shader program. And he links the program, fine. Print program info, that's fine as well. And then he starts doing some proper OpenGL stuff here, which is interesting. So this is OpenGL 2.0, and I don't really understand it very well. But yeah, I think GL shader source makes an array of strings because you could provide multiple sources. Yeah, that's why it does an array of strings. So you can basically just compile like 500 different vertex shaders at once. So yeah, it's good for that. But in this case, he's only got one here. Yeah, so he's got. I'm gonna be honest, I don't know what this is doing, but what is model load? Oh my god, what has he got here? Don't tell me he's written a parser for an object file. Because that's amazing, dude. If he did that, then it's amazing. No way, he's actually done that. So do we have an object file somewhere in here, like a 3D object file? It does. That's really good, Ayub. If you're watching this in the future, man, well done on yourself. This is great work. So we've got, yeah. I mean, it's not really a hard file to parse, but it's still, difficult enough that most people would just get a library to do this. But you've done it yourself, so it's not bad. Nice. Let me actually show you guys what it should be looking like if it did run. Are you a student or are you a professional working at a company? I am a professional working at a company, dude. Let me see, does Ayub send this stuff? Oh, it didn't send it to me. But basically this program is supposed to show a teapot and it just benchmarks that. Obviously we can't compile it, we can't run it on my machine because it's just not working. He has to fix that. But I'm very impressed that he wrote a header just to kind of parse the object file, and that's very interesting. I am absolutely not gonna have time to review this whole thing in today's stream because I would need to learn how object files work, which from the looks of it isn't too difficult. It's just a simple kind of CSV-like file with vertices, vertex information, I guess, right? I don't know what VT is. Oh, there's a table. Yeah, maybe there's a vertex table. Ah, okay, and then I don't know what VN is, but then I guess that F is a face. So it said it tells you the IDs of the vertices to use. Which is, yeah, it's really good. Really, really good. I'm very impressed that that kid managed to do this. By the way, this code has been written by someone who's like 13 or 14, so yeah. You can guess how that makes me feel when I see the kids that age doing this, and then me struggling to read a file sometimes in C++. But that's good. Anyway, so he loads the model here, which I guess loads all the triangles of things, and then position X, Y, Z. Position X, Y, and Z. Yeah, no idea what this is doing. And it's got texture information as well. I mean, cool. I think this function does a little bit too much though. I'm not gonna lie. Because it initializes the program, so it compiles the shaders, and then reads the model. Yeah, I guess that's all part of the initialization, isn't it? Yeah, don't mind it too much. Anyway, so he's got a few callbacks. I believe we'll set a callback somewhere. For example, mouse. Where's mouse at? Motion. GL mouse functions mouse, yeah. Yeah, with glutch, you kind of have to set callbacks to everything. So as opposed to glue, where you actually have some sort of event pod in there for getting information. With glutch, you just set callbacks everywhere. I'm not a massive fan of glutch, to be honest. I don't really know too much about it, but I don't really like the callback methods really. But whenever something happens with the mouse, it will basically come into this function and give you the state of the mouse. Are these simply enums? Because I think they are, right? If these are enums, we can just change it to a switch case, I guess. I mean, even if it's not enum, it's just an integer, we can change this to a switch case. So glut left mouse. Let's see if we can find a documentation for glut, the glut API. Glut mouse function. It takes in the int state. It takes in the int state. It may not be possible to the D's. Okay. I guess these are just enums, right? But my point would be, can we just put all of this stuff into a switch case? So what is he doing here? So if the button is left button and the state is glut down, everyone's a student. If you don't learn, you're not living. That is cheesy as hell, man. That's the cheesiest thing someone said at the stream, but I agree, man. I completely agree. I think you've got the right idea. I'm always learning. In fact, I learn something new every day. There's not a single day where I don't learn something. Not because I want, just because I have to. But yeah. Can I hide the element? Jesus, still. There you go. Can I hide this one? Amen. So hide the element. There you go. Yeah, screw the heart emoji. Yeah, I'm not too opposed to this code. I think it's okay. It's got a timer here as well. Again, not opposed to anything in here straight away. Print program info log. Print shader info log. Oh, we've been on this function already. Print GL error. Yeah. So this is a nice function. Yeah, not opposed to it either. It looks okay. So we get the error code, and we just print the error string. That's okay. Sorry, we print the error code here. Not opposed to any of that. Render scene. Well, this is an interesting one. I'm surprised that this is really small, because I was expecting the render function to be a huge one. But that's because he defers everything to model draw. What's the call list? Draw you into list. Dude, my man Ayub actually did an entire object file renderer. And I'm impressed, to be honest. I'm still impressed. I've said this before. I'm impressed. So this shows you guys that, you know, no matter how young you are, no matter where you live, you can always learn stuff and then develop something really cool, like this one. I would think most of this low-level OpenGL code is effectively C code. In a large project should probably be abstracted, but for a small project is not needed. Yeah, so you know, for this project here, he's only using it to render one particular object type. So it's okay not to abstract things now, because, you know, as soon as you start abstracting everything, you're just going to spend a lot of time doing a bunch of stuff that you may not need. And a good example of that is a project that I had somewhere in my machine. Let me see if I can find it. I think it was called Discotheque. Yeah. Was it Discotheque? I can't remember now. But this is something I did on stream ages ago, where we pulled in Qt6 and glue as well with Qt. And the idea was to create an audio player, right? And what actually ended up happening is I spent so much time on the GL abstractions here. I'm still not finished, by the way. I still probably need to go back to this at some point and actually do something that half works. But yeah, I mean, I did so many abstractions that in the end I probably didn't need, because all I needed to do was just render a few bars. So yeah, I agree with that comment. Just to make it clear, I agree with the comment that you don't always need to abstract things when you don't need it. And in this case, I would argue that Ayub doesn't actually need it. He's just doing like one particular model rendering. But of course, if you wanted to do like, maybe he wanted to read other 3D object types. So for example, you know, object files are one of them. There's like FBXs, there's like Maya files and stuff. Then you'd have to abstract all the functionality for like reading a 3D model and then putting it into, you know, OpenGL structures. but in this case, it's fine. Like, yeah. I mean, I like it. I mean, I'm gonna push this now. I think, you know, we probably had it here, but obviously the main bread and butter of the code is here. You know, this file here, object.hxx, is where the magic happens. So he's got a class called model where he reads an object file like a teapot, and then loads it all into, you know, nice OpenGL, OpenGL structures. So this will be nice to review in the future. But for now, I'm going to leave it as it is. So let's just push this before I forget. By the way, have you guys, the ones that are watching the stream at the moment, if you guys have any like projects you want me to review, just send it to me. I'm happy to do a stream review for it. Give you guys some tips on how you can improve your overall project. In fact, last time we did something like this, we got something like 600 viewers. So I might change the title to something a little bit more clickbaity for the future. So like I'm absolutely scrutinizing a viewer's project or something like that, or making a little kid cry or something like that. that would be interesting. Where are we anyway? So we are in YouTube. What did I actually change? Yeah, we've made some changes, right? We made some changes. Did I change anything else that was important? No. Oh, why is push? Oh yeah, because I meant to do commit. And I think that's it. Like we've given him some feedback, and if he does actually look at some of the PR code and he understands them, he can basically replicate the same changes everywhere in his code and make the project a little bit better. So I am gonna again create a little pull request on that. So electro bench, removing mallocs, abstracting functions. Okay, I'm not going to create a description. I think it's fairly self-describing now. Anyway, I think that was the stream. There's no point in starting something else for like another 10 minutes because I'm actually going to go to bed very soon. I'm like absolutely really tired today. Worked the whole day again, did some lunch, made some food after work, and then came here. So yeah, you guys got all my attention today. But I thank you all for joining today, especially Slim, Jean. You guys have been here for a long time, so you know it's good enough. It's good to see you guys here on the stream again. And I will be doing some more content this week. If you guys have any suggestions, you know, feel free to shoot them to me. Yeah, got any questions? Talk to me on Discord. You know the drill. But I think this stream is gonna be here now. So I will see you guys next time. And bye bye. Good night.